This is number 47. This is a box that's getting thrown up the ramp. The initial velocity is 5 meters per second. If you do a free body diagram for it, it's got mg down, it's got a normal force, and again we're dealing with a no friction case. Friction would have been down the ramp. So the velocity is up the ramp, but there's no force of motion. It's a common misconception that we want to put some applied force on here. Somewhere before this problem started, there must have been a force acting on it to give it this velocity. But as far as while the box is on the ramp, it has the velocity of that, but these are the only forces acting on it. And so realistically, when we think of our tilted coordinate system, you can put x up or down, it doesn't really matter. The velocity is up, but the acceleration is going to be slowing this thing down. And so if you do an F equals ma for it, mg sine theta is down the ramp, and that equals ma. The masses actually cancel, and so we get an acceleration that's g sine theta, which is some value. Okay? It looks like the angle is 20 degrees, and I didn't type that number out. Okay? But let's just pretend that you can get that on your own. And so what we want to do is figure out how far it slides up the ramp before this acceleration slows it down. And so in that we're going to use the v-squared equation. If you think about the v-squared equation, the v-squared equation relates velocity, accelerations, and distance. We want this thing to stop. We know initially it's traveling at 5. It's going to slow down at some acceleration rate, which we know is g sine theta. And then how far up x is it going to go? And you get x equals 3.73 meters. Again, the free body diagram, there's no friction. Friction would be down the ramp. Friction would oppose the motion in this case. But there's no force of motion. There's no force. This is a velocity. Do not put a velocity on a free body diagram. Free body diagram are only for forces. The only force acting on it is gravity. Gravity slows it down at this rate, and it takes this amount of distance to slow down that velocity to a stop of 0.